Good morning, class. As I promised you yesterday, I am currently in a training session learning how to coach and train my fellow teachers. And you have, I'm sure, a phenomenal substitute all lined up. And although the meme says the sub is going to force you to watch a long, boring video and then give you the wrong note sheet, not sheet, hopefully that's actually not the case at all. It's my intent to make this video pretty efficient, and I hope most definitely you have the right note sheet. Okay, you should have picked up a blank one when you came in, and we're going to fill it in for a while, and then you'll have a nice homework. So, all right, let's get started. We're going to talk about applications of right triangles, and so we talk about angles of elevation and depression. So first we'll take some notes and we'll go over some vocabulary, and we're going to talk about angle of elevation. Oh my goodness, why is this not moving? Come on, baby. Can you please move? Why? Oh, that's nice. There we go. Come on. You know something in my life today, I cannot even tell you. All right. So, angle of elevation. Let's write down some terms. We've got this guy here, right? That's the line of sight. So you need to picture a laser coming out of your eyeball to whatever you're looking at, whether it's, the top of a building or a hot air balloon or the sun. I don't know why you would be looking at the sun, but I guess it could happen. So it's the angle between the line of sight and the horizontal line. And this guy here then is called the angle of elevation. So your hint there is that to elevate means really to go up, right? Or to raise something up. So it's from the horizontal up. Angle of depression. We're going to get a blue color because depression, like blue, like down, So this time, the angle of depression, the frame of reference, is this adventurous young fellow here in the hot air balloon who has got a line of sight in the downward direction, checking out this person down here. And so there's the line of sight. And here's the horizontal. So again, in these instances, you always have a horizontal, 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 horizontal. And this guy here then is the angle of depression. Angle of depression. So start at the horizontal, go down. The other one is start at the horizontal, go up. Oh my gosh. I honestly, at this day, I cannot wait for this day to be over. I have 28 minutes left in this day. All right. So basically, when we're solving these problems, you're probably going to you will be given usually two of the following three things to set up your problem, and you are going to need a trig ratio to find the third. Okay. So maybe we're going to tell you how far away from an object the viewer is. Maybe we're going to tell you what the altitude is from the ground to the object. It's also known as the height. What is the angle between the horizontal and the line of sight? That could be something else. So in other words, the angle of elevation or the angle of depression. All right, and so the procedure that we're going to follow here is, first of all, draw a picture if one isn't given to you. Label all the information on there, do at least that much, and then determine what trig ratio you're going to use. All right, what trig ratio? We mean these guys, right? Either sine, cosine ratio, or the tangent ratio. And then you set up and solve. So it's a lot like what we've been doing. All right, so here's a nice example for you. We've got a hiker, and the hiker is standing 220 feet from the base of the hill. So immediately I think I'm gonna get a nice bright color here. So he's standing 220 feet from the base of the hill. So that means this distance right here is 220. At least that's what we're calling it. The angle of elevation from where he's standing to the top of the hill is, how tall is the hill? Listen for this right here. So notice there's absolutely no information about the hypotenuse, nor does anybody even care how long the hypotenuse is. Therefore, we are going to use the tangent ratio. So we would say tangent of 29 is equal to h over 220. And you would solve this equation for h, and you should get 121.95 feet. You know what, I feel kind of bad about this. I feel like I keep telling you to do 3 decimal places. And I keep telling you what we're going to do, so let me fix that for you. 948. There we go. Okay. Alright, let's try another one. So now we have a 30-foot ladder forming an angle of 50 degrees with the ground when it's placed against a brick wall. So how far up the wall will the ladder reach? How far away from the base of the wall is the ladder? So we got a 30-foot ladder. That's this guy. And how long the ladder is. Forms an angle of 50 degrees with the ground when placed against the wall. How far up the wall is it going? We'll call that H. And how far away from the base of the wall is the ladder? I'm going to call that X. So I do know the hypotenuse. I got this angle. This is the angle of elevation, by the way, if you're standing at the base of the ladder. And if we want H, we're going to use sine. So sine of 50 equals H over 30. And if we want the distance away from the wall, the X, we would use cosine. So in that case, cosine of 50 equals X over 30. And if I multiply 30 times sine of 50, I get 22.981 feet. So about 23 feet up. And 30 times cosine of 50 is 19.284. 19.284. So a 30-foot ladder, you put that 23 feet up the wall and about 19 feet away from the wall. Alright, Alex. Which Alex is it? Is it Alex G? Is it Alex W? Is it Alex R? Is it all of them? Just kidding. You know what? It is all of them. There we go. Alright, so they're standing on the ground. They look up. They see the plane flying in the sky. If the plane is flying at an altitude of 2 miles and the distance along the ground is 5 to a point directly below the plane, what's the angle of elevation that they have to look up at? So it's flying at an altitude of 2 miles. Altitude is going to be a vertical distance. And the distance along the ground is 5. And the question is, how much is this guy here? Again, notice the absence of hypotenuse. So we're going to use tangent of theta equals 2/5. We're going to use tangent inverse to solve for this. And so the angle that the three Alexes are gazing up at the plane at is 21.801 degrees. How you doing? Doing okay? These aren't too bad, right? Alright, then we got Michael, okay, whose eyes are 5 feet off the ground. Alright, notice that Mikey's foot is doing much better. He's not wearing his boot, okay? Is standing, let's see, his eyes are 5 feet off the ground. Okay, so this is here. So we are taking into account Mikey's height. He's standing 30 feet away from the base of the building. And he's looking up at a 50-degree angle of elevation. I think that's kind of steep. to a point on the edge of the roof. Why? What's on the roof, Mike? What are you looking at, Mike? To the nearest foot, how tall is the building? Oh, it's a little more intricate this time, is it not? Yeah, so basically if we use this triangle, we're going to call this piece of it here y, because that is the direct part of the triangle. So I could use a tangent equation and say tangent of 50 is equal to y over 30, and that's fine. And so I would get the part that's just the y, and that's 35.753, okay? But it says how tall is the building, which is h. So it's really not that bad. It just means you have to take the y portion of it and add 5. And then, of course, you get 40.753 feet. So a building is about 41 feet high. Nice. Okay. Well, guess what? We got more examples for you. How do you like that? Are you getting tired yet? Yeah, we should do some angle of depression. Okay? So, we got the little boy. He's standing on a cliff above the water. He sees a boat that's 200 feet away from the base of the cliff. It is 315 feet away from him. What is the angle of depression from him to the boat? So we have some pieces of information here. And it says the boat is 200 feet away from the base of the cliff. Where's the cliff? It's over here. This is the cliff. Sort of a primitively drawn cliff. Okay? The boat is 200 feet away from the base of the cliff. It also says the boat is 315 feet away from the boy. That's the diagonal distance. Okay? So, the question is, what is the angle of depression from the boat? So, the angle of depression, technically, is this angle right there. Alright? That is the angle of depression. This one. It's always made from the horizontal. There's a lot of people that really desperately want this sucker in here to be the angle of depression. It's not. Okay? It's not a decision we get to make. Somebody else made that call a long time ago. The good news is the angle of depression is actually congruent to this guy down here. So angles of depression and elevation will be congruent. Maybe you remember your parallel line theorems from geometry. So we want that guy. So how do I get that guy? By finding this guy right here. I'm going to call that alpha. Okay? Alright, how do I find alpha? Well, I've got the adjacent side to alpha, and I've got the hypotenuse. That's kind of screaming for cosine. So cosine of alpha is 200 over 315. I'm going to use a little inverse. And so cosine inverse of 200 divided by 315, 50.586. 50.586 degrees. Okay? Alright, and so those angles are equal, and so I do have the angle of depression there. Now we got a princess. What's she doing up there? Princess, she's on the top of a 167-foot tower. This is funny. Tower. She's looking down at an angle of 37 degrees angle of depression. Again, see this mark for you here? That's the angle of depression. Okay, it always is from the horizontal. Always. She's looking at a package. That's kind of funny. Attached to a rope on the ground. How long is the rope? For different right? So, again, using the parallel line theorems, if that angle right there is 37, guess what else is 37? Oh yeah, this guy. Alright? And so I have this side of the triangle, that's 167. I have this little angle in here that's 37, and I want the hypotenuse. This is a sine situation. This is a situation for sine. 167 over b. Now, these guys can switch because we're solving for d, so we just swap the factors out. means D equals 167 divided by sine 37. And that equals 277.494 feet on a long rope. Why are they doing a princess? Why don't they just like call it like the princess? Who's that princess from Tangled? Why don't they just make it her hair? Alright, we're almost done, my friends. Almost done, and then you can get launched on your worksheet. So, from an airplane at an altitude of 1,200 meters. There's the altitude of the plane. 1,200. The angle of depression to a building on the ground is 28. Again, please be careful. This is the angle of depression by definition. Okay, not that other one down there. Find the distance from the plane to the base. For this guy right here. So, if that angle of depression is 28, this angle down here, whoa, sorry, fly landed on my screen. I don't like flying. Alright, looks like this is another job for sine. So we have sine of 28 equals 1,200 over D. And again, that means that D equals 1,200 over sine of 28. So that gives us, oh my goodness, 2,556.065, whatever M they're using, meters, miles, maybe. I guess it could be miles. That's a weird looking building. Is it me or is that a weird looking building? You're saying don't be judgy? Okay. Alright, last one. We got the sonar operator on the battleship, alright, detecting a submarine at a distance of 500 meters horizontally. Thank you for that. And an angle of depression of 37. How deep is the sub? How deep is the sub? There was an old Bee Gees song called How Deep Is Your Love. That reminds me. How deep is the sub? Alright. How deep is the sub? Anyway, I'll call that Y today. And this is a tangent looking thing because we got no hypotenuse information. So, tangent of 37 equals Y over 500. Yes, Y. 500 tan 37. 376. Ooh, 777. That's a nice way to end, don't you think? Alright, so, my friends, hopefully that gives you more than enough to kind of get you ready for what's next is your worksheet. Okay, so the answer key will be posted, alright, later on. And that's it. So, if you have any questions at all, please don't hesitate to email me, right? Okay, email me. Make sure you spell my name right. You can send me a text at my Google Voice. Okay, it's not my personal cell, it's like a Google number. But I will get the text message, or I will get email. All right, good luck. See you tomorrow. Bye.